name is Rebecca Penfold and my project is a thermoregulating baby carrier for cold climates. My inspiration for the project came from looking into current baby carriers on the market and determining that there was no carrier that could take your infant out into cold climates. And when I interviewed parents, they said they were worried about taking their infants out when they were quite small, so under 6 months, into cold temperatures below 0 degrees. So I came up with a solution involving thermal smart fabrics to keep them at a constant temperature. I'm looking at Russia, Scandinavia, Northern America, those kind of areas where they have a long period with cold temperatures below 0. I'm currently in the last stages of prototyping the final model for the degree show, and so I've put most of it together. Sewing and soldering is kind of all that's left, really, just a small amount. It's quite a complicated product. There's a lot of, because of ergonomics wise, and most of the technology I've used is not being used greatly, and it's not greatly advertised how you put it all together. So I've kind of come up with my own solution of how I would use the fabric and how it would all integrate into the product. So I think if I was to take it into production, it would still be quite far off. I've done user testing already, and I know some of the parts without guidance can be a bit complicated, and also there's a bit of a sizing issue because obviously they'll be wearing quite big coats, so I do need it to probably go larger than the average, like 95th percentile. With my project I can prove that the whole thing works, I guess, is what I'm hoping to prove, and that yes, it might have to be developed further. There's like some slight problems I've discovered through user testing. With the prototype I hope to achieve kind of a high standard finish, not quite manufacturable level, but to show that the electronics all work. So I have the thermal smart fabric, and I hope to show that the current runs through and it heats up, and I hope to show that with a few minor adjustments the general carrier will fit a wide range of the population, which I've partly done through user testing, and I hope to show that it kind of looks interesting, I guess, to people when they come to view it. Everything's kind of come together quite well, and I have something I can show to people, but I think, yeah, because it's used on such a vulnerable target audience, obviously under 6 months of age, I think obviously it would take a lot further development to ever be at that stage that someone would actually purchase it because of safety and testing. In regards to the electronics that I've undertaken for the project, I've done breadboarding to determine kind of thermistor values that will be a cut-off, and I have programmed the microchips with Picket 3. And I have also made a PCB to put it all together, and then I've been using thermal smart fabric on the panels and connected this with conductive silver thread, and then I've been working at ways to connect the whole thing because they need to be in parallel, each panel, so they all require the same voltage. So I've been kind of coming up with solutions to that. In regards to how much time I've spent on electronics for this project overall in compared to other aspects, I'd say I probably spent about 50% of my time. My aesthetic model, obviously I didn't know how to sew or anything really before, but that was relatively easy to pick up, and once I kind of learned that, I actually had to send it off to a manufacturer to manufacture because of the industrial grade machines that I needed to produce it. So when it came to the electronics, that's all my own work, so that's why it took about half the time. I have used this kind of mock-up and put it onto the computer on Livewire, which is a circuit kind of diagram drawing software, and then I have used MPLab, which is a C programming software, so where you write the source code in the header files, and I have put this, then programmed it onto the microchip. And then I have also used Design Spark, which is a PCB drawing equipment software, to create my PCB from the Livewire, the circuit diagrams. The biggest electronic challenge I've experienced during the project is the thermal smart fabric, because there wasn't that much documentation available through the internet or through literature, and also the manufacturers of the fabric are quite busy, so they haven't really been able to give any documentation or guidance on how you'd actually set up the fabric. So because of they're resistive fabric, so they reduce the flow of the current, so they give off heat. So I've had to kind of come up with small panels. Initially I wanted to do one large panel, but now I've changed it to small panels and had to come up with a way to make sure the current spreads evenly through the surface. In regards to how I changed my project and how it was compromised because of the problems I experienced with the thermal smart fabric, I'd say obviously it slowed me down slightly, so it's I think I should have been a bit ahead at these stages. It just meant that the general heat distribution throughout the fabric is slightly compromised because obviously it's in patches rather than a constant throughout the fabric, and also it meant that I'm slightly worried about it short-circuiting in reality. Like in the actual product, if I was to put this into the aesthetic model and the infant was to move, that the wires or the conductive thread would touch, and that would compromise the working of the project. Working it out yourself kind of makes you learn, I think, things a lot quicker and a lot deeper, I guess. And I think I wouldn't have discovered this if I'd just literally known exactly what to do through documentation. So now I've had to come up with my own solution, and I kind of understand fully how all the electronics function in regards to my specific project. When I started working on the project and I knew that my project was going to involve electronics, I wasn't very daunted. Obviously I do a BSc module, so we do quite a lot of electronics anyway, and at first I didn't think the electronics would be that complicated. As it's developed, there's been problems and I've had to come up with my own solutions, mainly with the smart fabric, and also the programming was a bit of a hassle, which it always is. So I think it was fine, and it's kind of developed, and I think as the stages have gone on it's got a little bit harder, but it's small stages, so it's not too difficult. I feel like I've pushed myself harder than I thought initially I would have to for this project. Obviously, as I said before, there was no really relevant information that could help me along the way, so I've had to come up with my own solutions, which I guess creativity has played a big part in that. If I was to start over and redo what I've already constructed in the electronic side of my project, I don't think there's that much that I would actually change. I would probably spread the panels out further to stop the short-circuiting problem that I talked about earlier. But other than that, I've kind of learned stage by stage, so I couldn't really have changed it unless I started over again and I already knew what I already know. I think that yes, sometimes it has taken up quite a substantial amount of my time. Things tend to go wrong, components break, programming no longer works, or you can't find the problem until the end stages and you've spent a lot of time trying to find the solution. However, it's provided me with a lot of knowledge, and when I came obviously to do my final year project, it's provided me with a confidence to kind of undertake whatever I wanted to do. And obviously I decided to do this thermal smart fabric, which we have not carried out any study into this throughout my time studying. So yeah, I feel that when I leave Loughborough, I will have the confidence to kind of do any projects that I want to, really. Throughout my time on placement, I kind of had the confidence to talk to the engineers, and I kind of always tended to know what they were talking about, maybe not quite in as deep a context, but I always understood what they were talking about. This is the general aesthetic model of my baby carrier. These panels will be in the front and back face of the baby carrier, which will allow a constant temperature to go through to the internal environment of the baby carrier to keep the infant at a constant 25 degrees surrounding temperature. When the user turns on the carrier, a voltage will travel through each panel individually in parallel through the conductive silver thread, which spreads out through 5 channels to spread out the voltage throughout the whole surface. And then it will leave and enter through these brass poppers, so a multi-core wire can be connected, which will travel back into the PCB. And then if we look here at the breadboard, there's 6 thermistors which will be connected to 6 panels on the carrier, 1 near the head, middle and the lower end of the infant, to determine whether the temperature is above 30 degrees or not. If the temperature is above, then they will be read through the microchip and no power will leave the microchip to power the fabric. However, if they're below 30 degrees, then this value will be read by the microchip, which will then allow power to be travelled to the fabric to create heat around the baby.